Hi everybody, today we're going to talk about the central limit theorem, and in this video I'm going to show you how to solve problems using Desmos. If you like to do these problems in Excel, I have another tutorial that does the exact same problems but just uses Excel instead of Desmos. Our first problem says a population follows a normal distribution with a mean of 199.6 and a standard deviation of 44.9. We want to find the probability that a single randomly selected value is less than 205.4. We can start by typing normal dist, or you can open up the keypad, go to functions, and look for distributions. In the distributions, you'll find that the first one says normal. Once you have the normal distribution, you need to add the mean and the standard deviation. Our mean was 199.6 and our standard deviation was 44.9. I'm going to click the zoom fit to see the graph, and I'm going to click find cumulative probability. We want the probability that x is less than 205.4, so for the max I type 205.4 and it gives me 0.55139. I'll call that 0.5514. What I like about Desmos is that I can visually look at the graph, see that the mean is here at 199.6, look at our value of 205.4, and get a visual representation of what the probability is showing us. Next, we're going to take a sample of 213 from this same situation and find the probability that the mean is less than 205.4. Because we're looking for the value of the mean and not for a value just of an item x, we're going to use the central limit theorem. We're still going to use the same mean that we used with our regular distribution, but now we're going to use the standard error of the mean instead of just the standard deviation. So we'll take our 44.9 and we'll divide by the square root of 213, which was our sample size. Back in Desmos, we just want to change the standard deviation to the standard error of the mean. We'll divide the 44.9 by the square root of 213. If you want to, you can readjust the graph so you get a better view of it, but you can see our answer is 0.9703. Let's take a second to compare the two answers we've got so far. Our first one was the probability of x, which is a single value. Our second one was the probability of x bar, which was the mean of a sample that we drew. So just a single value, use the normal distribution. When you look at the mean of a sample, then you're using the central limit theorem. Our second example says a study found the average sleeping heart rate of a child between 8 and 11 was 89.1 beats per minute with a standard deviation of 8.2 beats per minute. If we assume the heart rates were normally distributed, find the probability that a randomly selected child would have a sleeping heart rate over 95 beats per minute. So back to Desmos, we type normal dist, we put in our mean of 89.1, our standard deviation of 8.2, click on zoom, click on cumulative, and then we want over 95, so we put 95 as the min, we leave the max at infinity, and it says our answer is 0.2359. Again, you can refer to the graph to see your mean at 89.1. You can see over where we're looking at 95, and it's shaded to the right to show 0.2359 of the graph. Let's say a group of 67 children are selected from this study. What's the probability that the average of their heart rates is over 95 beats per minute? We go back to Desmos and we want to change standard deviation to standard error of the mean. We're going to divide by the square root of 67. This gives us a very, very small number. It says 1.937 times 10 to the negative 9. That's essentially 0. When you look at the graph, you don't see any of the areas shaded. This is too far off the graph for there to be much less. Anytime you see something in scientific notation, you know you can just put in 0 for the probability. Our last example says the average time to run a marathon for a person 30 to 40 years old is 4.4 hours with a standard deviation of 0.25 hours. Assume the distribution of time to finish a marathon is normally distributed. Find the probability a runner finishes a marathon between 3.8 and 4.2 hours. So we'll bring back our normal distribution with a mean of 4.4 and a standard deviation of 0.25. We'll hit cumulative. Our low will be 3.8 Our high, or max, will be 4.2. It says the probability is 0.203657. We'll call that 0.2037. Let's find the probability. The mean running time for a group of 15 randomly selected runners is between 3.8 and 4.2. We'll change our standard deviation to standard error of the mean by dividing by the square root of 15. We can zoom fit and see that we get 0.00097. I'll call that 0.001. We have this very tiny probability that we don't even see on the graph. As a quick recap, remember that when you're finding the probability for a single value, use the normal distribution. When you find the probability for the mean of a sample, use the central limit theorem. Good luck.